So this problem says solve the system of equations. If the system has no solution, say it is inconsistent. Graph the lines of the system. So for this problem, we're going to do the elimination method. But before we do, we're going to set it up in such a way that it makes it easier to do, because this 1/2 and 1/4 thing might be hard to deal with. So what we can do to get rid of that is, if you look at the top, I can multiply everything by the LCD, which is 6. And for the bottom, I can multiply everything by 12. And then I can rewrite these equations and use those equations I get to solve the system of equations using the elimination method. So this is going to give us 3x plus 2y equals 18. And then we're going to get, for the other one, 3x, and that's going to be 3 and the 12, that's going to be 4. 4 times 2 is -8. So -8y, and that's going to equal -12. Okay, now we're going to do the elimination method. So that what that means is we have to make either our x's or our y's opposite in the two equations. So opposite, so for instance, if I had a 3x, the opposite of 3x would be -3x. So I'm going to get rid of the x's here. So that's why they call it the elimination method. Oops. So I'm going to multiply the bottom one by a -1, because then my x's will be opposites. So then that's going to give us 3x plus 2y equals 18. And then for the other one, it's going to be -3x plus 8y equals +12. And when we add those together, the 3's are going to cancel, and that's going to give me 0. This is going to give me 10y, and this is going to give me 30. So then when I divide by 10, y is going to equal 3. So again, we have to find the x as well. So which one do we sub it into? I'm going to use one of these new ones we created here, and I'm going to put it in the top one. So 3x plus 2, and then I put the 3 in for y, equals 18. So that's going to be, 3x plus 6 equals 18. And then subtract 6, so 3x equals 12. And then divide by 3, so x equals 4. So my ordered pair will be, and I'm going to write it over here, 4, 3. So there's the answer to this problem. Now we're going to graph it. Okay, now for graphing these, what we're going to do is for the top one, I'm going to just put it in slope-intercept form, because that would be easy enough to do here. And again, I'm going to call this one 1 and this one down here 2. So for number 1, I'm going to get y equals -3/2 x plus 9. And for the other one, I'm not going to do it in slope-intercept form because it's not going to give me a nice y-intercept. So I'm not going to deal with it that way. But that one, I can pick 2 points. So one thing I see right away is if I put a 0 in for y here, I know that 12 is a multiple of 3. So if I put a 0 there, that's going to give me a nice point for 2. So I'm going to do 2 points for the second one. So the first point I'm going to use is 0 for y. So that's going to be -4, 0. And another point is, and I hate to tell you guys this, but the point 4, 3 is also a point. And if I wasn't sure about that, if I put in a 3 here for this y here, that's going to be 24. And when I add 24, what's going to happen here? I'm going to end up with another 12 here. And it's going to be a +12 when I add it over. And then 3 goes into 12. So I'm going to get the point 4, 3. Now all I'm going to do is graph these two lines. So the first one, I'm going to start at positive 9 on my y. So 1, 2, 3, 4, 5, 7, 8, 9. Oh, good. I had enough, just enough for this point. Okay, and then I'm going to go down 3. So 1, 2, 3. And then over 2. That's going to put me here. And then I can keep doing this if I want to, so I can get a good line here. So down 3 more and over 2. 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 And that'll be the last one I do there, but that gives me a really nice line to draw there. So, and then for the other point, I just graph it. So negative 4, 0, 1, 2, 3, 4. And it's going to be there. And then 4, 3. So 1, 2, 3, 4, and then up 3. So it's right here. And then I can just draw a line there. So there's our graph, and our graph intersects at, if you notice, 1, 2, 3, 4. 4, comma, 3. So there it is, and I just kind of wanted to show you what that looks like. And plus, we used here the elimination method. So there it is, there's our answer, 4, 3. And we didn't have to do the graph here, but for an answer, but this asked us for it, so that's why we put it in. But the answer would have been simple enough. If I was just looking for the answer for this equation, I would have just gotten to this 4, 3 and been done. But this problem asked us to do the graph as well. So there it is.